Hey, Wilson. Okay, I think we'll start now. It's 11:05. Uh, Maybe people will join after this. So thank you everyone for joining. My name is Vishal Changrani. Thanks for joining again. This is our first Flow Node Operator Office Hours. And the reason we wanted to have this is because we have kind of interacted with you all on Discords, on email, and on like private Telegram chats, etc. And I almost think that I almost know each one of you by now. But we wanted to have this like touch points on a regular cadence where we could like talk more about flow node operators, flow node operation, discuss like what's coming up with flow, and also like exchange ideas and maybe foster a sense of community between all of us node operators. So that's the reason for having this flow node operator office hours. Can you change the slide? Here? So today our agenda is basically we'll go through a round of introduction. I'll tell you a little bit about myself, and then I'll turn it over to JP, who will introduce himself. And then JP has also been kind enough to kind of put together some slides explaining how Dapper Labs runs their nodes and how we have it all set up on our end. And then maybe we'll leave some time, like for 5 minutes, for question and answers. But feel free to like ask questions in the middle if you have. So yeah, about me, my name is Vishal Changrani. I'm part of the Flow team. I recently moved into the product, so I'm now a product manager. I joined in October 2019. When I joined initially, I worked on the networking layer, and then I worked on the access node implementation. I also closely work with all of you, the node operators. So one of my duties now is actually actively doing the support for the flow node operators. I'm also working with the access node team to kind of figure out the next milestones for the access node and all the deliverables for this year and the coming year. The third thing that I'm working on is the flow network availability. So making sure that the network is available 24/7. Part of that is spoke management. So whenever we have spokes, I'm making sure that I line up all the communication, all the changes that are supposed to go in that spoke. The other thing is incident management. So whenever there is a flow mainnet or testnet incident, how do we manage that? How do we report that? And obviously try and make as few incidents as possible and have as little downtime as possible. Part of that effort is also like building these SLA, SLOs, dashboards, and measuring our metrics. That's actually an ongoing effort right now. So yeah, that's kind of been my journey so far through Dapper Labs and through Flow. Over to you, JP.
Hi all, my name is Jean-Paul. I also go by JP. I'm the dedicated SRE member for the Flow team, and I'm the first of several members that will be dedicated to supporting and improving Flow's infrastructure. I've been working at Dapper Labs for about 7 months now, and I've really enjoyed working with the Flow team to improve our infrastructure and kind of make some different strides. Alongside supporting and managing the Flow infrastructure, I also help develop automation for the configuration of the Flow network, and I'm also responsible for the development and automation of the support process that's used to upgrade our networks. And Vishal and I work closely on that. So lastly, I also assist in the monitoring of our network, and I help configure alerts to notify us of operational and infrastructure issues. So today I'm going to speak to you all about how we host, provision, and manage our nodes at Dapper Labs. So at Dapper Labs, we leverage several hosting services that allow us to streamline the deployment and management of our networks and nodes. For DNS, we leverage Grafana. We use Cloudflare. Getting all mixed up. For DNS, we leverage Cloudflare. We leverage Grafana Cloud for monitoring, alerting, and observability. And currently, we leverage Google Cloud to actually host our networks and nodes in the cloud. But we have positioned ourselves to support multi-cloud deployments. In the future, we hope to increase resiliency against cloud provider failures, and we may consider hosting nodes on other cloud providers. In general, we've taken an agnostic approach to the way that we manage our infrastructure so that we can easily provision and deploy nodes on any provider anywhere. As for how Dapper Labs provisions and manages our nodes, we lean heavily on Terraform. We leverage Terraform to create and manage the state of our cloud infrastructure, and we use it to provision the necessary infrastructure across the previously mentioned services. Specifically, Terraform is used to create all of the necessary resources within GCP and Cloudflare so that we can easily spin up a network with nodes that are publicly available. Once the network and VMs are configured within GCP, we leverage Ansible to configure the individual nodes. Using inventories and playbooks, Ansible is used to configure and manage VMs within each network. Furthermore, ongoing changes and deployments are made using Ansible. Using various playbooks, we're able to execute automation against our nodes and run ad hoc commands. For running the node software, we leverage Docker. At Dapper Labs, due to performance issues during initial discovery, we run Docker on VMs. Initially, when leveraging container orchestration platforms, we experienced some performance issues with some of our node types, some of our bigger nodes in particular. Therefore, the decision was made to orchestrate Docker on VMs rather than use an orchestration platform. Alongside node deployments, we leverage Docker to locally develop and test our software. And for those of you who do not know, we have a nice setup that can be used to locally run a Flow network. If interested, feel free to reach out to Vishal or I for more information on our local net setup. Now, before jumping into some of the configs that I'm going to show you all, specifically our Terraform configs, it's kind of helpful to understand what our networks look like at a high level. This diagram is a simplified overview of our Flow network architecture in GCP. For the sake of simplicity, I've outlined a single network that hosts our core node types and operational nodes that run Ansible and Prometheus within the network. With that said, as you can see on the right-hand side over here, we create a VPC in US Central with a single subnet, and we host all of our core node types. To manage these nodes, we deploy an Ansible host that can be used to execute automation against the individual nodes or collections of nodes. Furthermore, we leverage Prometheus to scrape metrics and custom metrics from our instances and our application. And in turn, those metrics are delivered to Grafana Cloud. On the left, you can see a separate VPC and subnet created in the US West region. We run a subset of our nodes in multiple regions to avoid regional failures. With that said, we do not currently run all of our nodes in both regions due to latency issues. In the future, that is likely to change, and we will support multi-region deployments that are isolated from regional failures. Now, it's worth pointing out that both networks are peered so that nodes can be managed from a central Ansible host and metrics can be scraped from a central Prometheus node. It's also worth pointing out that the nodes themselves are public and connect through the internet through an internet gateway. They have the necessary firewall restrictions to limit access to only the necessary ports. And access to the nodes and metrics is limited only to the internal Ansible host of Prometheus nodes. Now that we have reviewed the Flow network infrastructure, I will show you how we define and configure the nodes. I'm going to show you the Terraform configuration used to deploy our DevNet infrastructure, and I'm going to walk through some of the playbooks, or maybe a playbook, used to set up the network and execute configuration changes. So I'm going to swing over some code. So to start, we can review the Terraform configuration that is used to define a network. I've removed some sensitive info from this, but for the most part, the structure of the inputs and the modules that we use remain the same. So Terraform allows us to control the state of our cloud resources. It's a tool comparable to CloudFormation, Pulumi, and other different tools in the same vein. For us, we've abstracted the majority of our configuration to Terraform modules that encompasses an all-inclusive network. You can see this on line 4. For those of you who may not be familiar with Terraform, you can think of a module as a container for a set of resources. In our case, we have a network module that handles the creation of the networking, the DNS, the firewall rules, and the VMs. I'll dive into the module itself here shortly. What you're looking at now is the resource that makes use of this module. On line 4, we define the source for this resource, which is the module, and then everything else is variables, which is input. And so you can see the machine type, you can see the node counts that we have, and disk sizes, etc. And this allows us to configure this network and dynamically spin up new VMs or increase our disk sizes and so on and so forth. And so we have variables such as zone and region that allow us to kind of control which region and zone we deploy to. And we have different iterations and so on and so forth. So this one specifically for US Central, as I kind of highlighted in our network architecture, we deploy 2 different networks and peer them. So I want to show over here where we actually reference the US West. We create the US West network. And I want to highlight the node counts here, kind of as I was highlighting. We don't actually deploy all of our node types into that region. So this allows us to flexibly spin up a whole nother network with different nodes in an isolated region, and while not spinning up everything per se. And we can configure that as needed, and so on and so forth. And so lastly, I kind of want to shift over to this peering, these peering resources that are used to connect the two. I'm not going to spend too much time on this. You can just assume that this allows the networks to talk to each other and sets up the necessary communication. So I'm going to swing back to this testnet v35, which is our US Central definition for our network. I've removed out where we're actually storing these, but you can see that we're using this flow non-production folder, and then within that, the network module. And so I've copied over the files for this and the directory structure, so they all remains the same. And so I want to bring your attention over to the left-hand pane where we have this flow non-production folder. And then within it, we have the network folder and we have a node folder, which is a separate module that I'll talk about in a second. But within this network folder, I want to bring your attention to 3 different files. We have a main.tf, an output.tf, and a vars.tf file. To start out with, I'll speak on this vars.tf. This is what allows us to configure our network, and it represents the variables for the module. So in the case before where we were using it, all of those inputs are variables that are defined here. And I'm not going to dive into the actual definition or configuration of these. I just want to highlight that in our case, we structure our modules in such a way where all variables are in the vars.tf, and it's just good convention so you know where your files are at, or your variables are at. The output.tf just uses returns a couple outputs from the module, and those were used in the peering connections, but you can think of those as just return values from the module. And so now I'm going to shift the focus over to the main.tf. This is where the meat of everything is at. And I'm going to kind of walk through the different resources we use to spin up a network and run the nodes. And so starting on line 3, we define a Google Compute Network, which is a VPC. And this is going to be the VPC for this particular network and set of nodes. On line 10, we define a subnet that we use, a subnet resource that uses the variables passed in along with the network itself that was just created. Now, starting on line 19 and below, we define firewall rules. I've kind of removed some info here, but you can just assume these are the firewall rules for our network and internal firewall rules. So we define quite a few of those to give some flexibility and lock things down. And then starting on line 134, we actually define the nodes that we want to run. And I'll dive into how these work and how this node module works as well. But this node encompasses all of this specific node type and will create all of them. So specifically, it will handle the creation of all access nodes within this network. The majority of these are the variables are injected all the way through. We do define some specifically and pass them in within this module itself. But I do want to highlight on 140 this role variable that we're passing in. If we continue down, we do that for our collection, consensus, execution, verification, and they're pretty much all very, very similar and just different We inject in different variables so that we can configure them differently. And I'll highlight how that's done in here in a minute. Scrolling all the way down, just lastly, kind of want to highlight this Prometheus node and Ansible node that we were referring to earlier. And I also want to highlight this bucket that we create for our execution state. And we create one of these for each network. So coming back up to that access node that I was referring to, I want to show you that this source, so in Terraform, you can either reference remote modules that are stored in a Git repository, or Terraform or HashiCorp offers their own repositories and different things. Or you can reference them locally off the file system. In our case, since we want to encapsulate everything into a single module that is versioned, we reference it locally off the file system. And so that's I want to bring your focus over here to the left-hand pane again. And so within that same Flow non-production folder, there's a node folder that has a module of itself. And this would typically have a little bit more files, but for the sake of simplicity, I've kind of just want to focus on this one, so how we configure it for the access node. So once again, we have the variables file, same thing as before. And then we have this main.tf, which defines our resources, and a cloud init file. And I'll show you how that cloud init file is used here in a minute. Starting at the top, we use on line 2, we define an image. This really should be passed all the way through. Little room for improvement on our module creation. But then we define our template file that we use, and we dynamically load this cloud init based on this role variable. And that's how we load in this file, cloud init file. And I'll talk about that in a second. But then we go on to create the compute disk. We handle attachment policies, snapshots, snapshot policies on line 42, the actual instance itself on line 62. And then this is where the meat of everything is for how we configure the individual nodes and how we configure the boot disk, attach the disk, the NICs, the service account, and the labels, and so on and so forth. And then lastly, on line 130 and 143, we create static IPs and Cloudflare records for our nodes. Now, I do want to highlight here that we specifically use count due to the fact that the version of Terraform that we started with was, I think we started with 12. They didn't have more advanced logic functions or iteration functions to loop over modules at the time. So this is kind of a legacy design pattern. If we were to go back and redo this, we'd use for each loops over a module so that we can control the iteration higher up. I just really wanted to highlight that we're kind of using indexes here, and there's some room for improvement. So I want to bring your attention back to line 9, where we define this cloud init file. So for those of you who are not aware, cloud init is a software that allows you to run different commands and or create files or just run automation at startup. A lot of cloud providers wrap it, and you may be familiar with user data. This is often what they're doing. They're injecting user data into a cloud init script and or creating a cloud init script that will run at different stages of your boot process. So we leverage cloud init, which this is our cloud init file specifically for access. We use it to write files, which you can see on line 3, and run commands on line 167. And so we run different startup commands, and we define different configuration in Cloud Init. We lean heavily on Cloud Init right now. We don't, over time, we'll probably move away from it. It's powerful, but it's not great for managing configuration and versioning. I'm not going to go into all these files. It's mainly instance configuration. But I do want to come down to how we define our systemd services that run our containers on top of the VMs. And systemd helps wrap the Docker run command that is used to run the container itself. And we inject in different variables and such so that we can dynamically configure the execution of these. So lastly, I'm not going to go into this too much, but I want to shift focus over to how we use Ansible after we bring up the network. So we use Ansible playbooks to configure the nodes and network after the infrastructure is brought up. So these are not auto-configurable. We do have to configure them. And so here's one such playbook that we run to bring up our network and essentially get it ready for a deployment. And so this is one that references other playbooks over here, the Flow playbook that references our hosts and Common, Envoy, Prometheus, just some different playbooks. And we leverage inventories that I'm not showing here so that we can easily reference our nodes. With that said, that's kind of an overview of our Terraform and how we leverage Terraform. And it's just kind of a high level, quick overview of how we use Ansible and playbooks to configure it after the fact. I know I didn't dive into Ansible too much, just mainly showing you how we do it after our infrastructure's up. So with that said, I kind of want to open the floor up to questions and anything you all might have or might want to speak to, or why we did things the way we did it, so on and so forth.
Any questions? Cool. Yeah, we wanted to actually give you guys an overview of how our setup is. And we would like for the next office hours, actually, I was going to ask someone from the community to kind of share how their setup works. And the idea is just to help some sort of cross-pollination here where we can kind of learn from each other's setup and what are all the industry best practices. So yeah, thanks, JP. Thanks a lot for that talk.
Yeah, thank you.
Cool. On the next slide, yeah, I just have some reminders. Actually, I did edit this slide. Did we refresh it? Maybe? Yeah, that's good enough. Yeah, so just a reminder, we have our testnet spoke coming up on August 10th, and then the mainnet spoke on 24th of August. And you must have also received an email from me asking for feedback for the Metrica dashboard. So if you have not already responded, please do. We'd love to hear from you. That's actually all we had. Are there any other questions about the presentation or anything else?
Just one small question. Is the Terraform code still right? Do you still get managed your execution node with 7.5 terabytes of data store? Because since you grow up the Spark dates from 1 month to 2 months, we are hitting 15 terabytes of data.
Oh,
Yeah.
this.
That example was specifically for DevNet, not for mainnet.
Okay.
Mainnet's a little different, and it will have more data. Yes. So
Okay.
that definition of Terraform is specifically for the DevNet 35 network, and some of that has been a little fluid, as kind of you're pointing out, between networks. So it's not static between networks, but.
Okay, great. So I thought I have missed some parameter, but okay.
No, you're good.
Anything else?
I was curious, can you go a little bit more into like the decisioning around the new dashboards and like what it provides outside of like Prometheus metrics and Grafana that you guys currently use?
Yeah, for sure. I can start, and Francisco, you can jump in whenever you want. So the idea is like we wanted to provide all the operators, first of all, a way to kind of monitor their nodes, more than just the metrics that's inbuilt in the software. More than that, we wanted to have a way to kind of parse the logs and also be intelligently derive metrics from the logs. That's number one. Number two is we wanted to have like dashboards that all the operators could share and see what's happening with the network. That this is in particularly important because very soon we will be having more sort of cases of slashing nodes when the performance is not there or there is some other conditions that's met. So we wanted to have a transparent way in which people can figure out what's happening with their node and why would they be potentially slashed. That's kind of the second incentive of that. And then eventually, the third set of dashboard was like dashboards that anyone in the world could access. Obviously, we'll kind of hide away all the personal identifiable information from that, but something that anyone in the world could see on what's happening on the Flow network. That was kind of the incentive of having Metrica kind of build these dashboard for us.
Got it. That makes sense. Thanks.
Yeah, thanks for the question, though. Cool. We are at time, so thank you all for joining. I hope this was helpful. I do plan to have this on a regular cadence. So yeah, thank you. Thank you so much for joining. And I'm looking for someone to give a similar talk to what JP gave for the next time. So if you're up for it, just hit me. I'll include you in the next call, for the talk. Thank you. Thanks a lot and have a nice day. Bye.
Thank you.
Thank you. Bye.
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 Thanks, guys.